Zombie Apocalypse.
Okay, so good day everyone. Try na natin i-apply ngayon yung mga na-discuss kong principle regarding collapse mechanism. So let's start with the simply supported beam and having only a single concentrated load kasi we need to understand the behavior of the types of load that we're going to apply. So let's get ready to be neurorized. Okay, for the first problem, suppose that we have this beam. Notice that the concentrated load is located on the center. And we have this load, yung given dead load and live load. Okay, so PDL represents the concentrated dead load. Okay, this is the dead load. And LL means this is the live load. Usually, yan yung mga nomenclature na ginagamit in understanding design when it comes to factored. Okay, so also let us try to observe what's the question. So let us determine the plastic moment of the given beam span. But of course, before we start, this is the first problem that we're going to discuss for collapse mechanism. So let us try to search, ano ba yung mga connected codes dun sa pag-understand na collapse mechanism. Okay, first code to understand is 502.3.2 under limit states. Okay, so this line shall be based on the principle that no applicable strength or serviceability limit state shall be exceeded. So meaning, under serviceability, we are going to understand the condition of having unfactored state or at service state. According to the language of design, when we talk about service state, it talks about nominal condition. Okay, nominal or sometimes okay, nominal or something referred to unfactored, okay? So it is clearly stated here. Now, we need to verify, how do we connect the nominal or the unfactored state wherein whenever we consider LRFD or load reduction or load resistance and factor design, naka-factor yan. And don't forget nga pala, all appropriate load combinations are applied. That I'm going to discuss after this. Okay? So after this, we need to understand now itong code na isa, 502.3.3, which is the condition where you are going to identify the relation of the nominal and the ultimate. So dito tayo magre-decide load and resistance factor design. So meaning, R sub U represents required under ultimate, which is this is the factored factored state, and the R sub n is the unfactored, or let's say the nominal, and to connect them is the phi value. So we're going to appreciate due to bending because we need to understand reduction factors. Okay, reduction factor. Okay, now under this statement, we need to understand ano ba yung mga value ng reduction factor para ma-correlate natin sa ultimate, which is under factored R sub U, and R sub M, which is under nominal. Now, in section 506, in 506.1, let's start with the design members for flexure kasi when it comes to plastic moment, it talks about flexure. So, meaning, if you have a moment, then RU becomes MU, and Rn becomes M sub N. That's why it is just like this, So, ito yung equivalence ng M sub U. Okay? So, we are going to understand the use of P of bending for 0.9. And if you are going to convert that into an AST, then there is another code for that we need to understand on the design analysis concept. So, 1.67, or just around, I believe that is around 1.67 is 3 halves, more or less, near to that factor. But 4/3, yan. No. It's not 5. It's around 5/3, Itong value na 1.67, if that is converted into a fraction. Okay? So, itong 0.9 na ito, ang gagamitin natin for us to understand that moment correlation. So, therefore, note that MU is equal now to 0.9 of the nominal moment. Ngayon, as I discussed this on the principle, I have talked about that the nominal moment, okay, has something to do with, has a relation to, is related to plastic moment. Okay? So somewhere in the middle, we can safely say that Mn, no, should be less than or equal to a plastic moment, since the plastic moment, no, as discussed already in one of the theorems, no, sa tatlo yan, and we need to understand the second theorem that no value more than the plastic moment pagka tiningnan natin yung pinaka generalization niya. So this will be also the same concept that we are going to use every time that we discuss flexural analysis, that the nominal moment should not be more than the plastic moment. So therefore, there is a correlation between the two. Ngayon, what we are going to understand is whenever we analyze the beam under collapse, it is the plastic moment that exists. However, due to the loads that are given, then we need to convert that ultimate, because we're dealing with LRFD, into nominal. So therefore, we are going to convert later that the nominal moment, no, or I'm going to write on the other side, on the right side of the screen, since Mn is equal, since M is equal to phi of Mn, then we can safely say that Mn is equal to Mu over phi, okay, less than or equal to the plastic moment. Now, let us take the sense of the equal sign. So, i-disregard muna natin yung less than na sign, no? Yung equal sign muna ang checkan natin dyan. That's why we're now going to consider the equivalent plastic moment, because in our next video lecture, the next concept to consider is what if the plastic moment is taken from the inherent property of the section. So there will be a new discussion regarding this, tsaka yung existence ng yielding moment. But for the meantime, let us analyze this first and apply, no? Okay, so another code to review, no? Under 203.1, dito na papasok yung load combinations. That's why, sabi dito, the most critical effect can occur when one or more of the contributing loads are not acting. So we are going to see the most critical, meaning, ano ba muna yung selection ng most critical? Note that in the stress review, stress is equal to force over the area. Okay? In the critical sense of design under factor state, we need a larger value. Kumbaga, dapat tataasan natin sa stress na expected. Equal, siyempre, to have a larger stress, we need to have a larger force but a smaller area. So, dito tayo focus. Kaya notice that we need to amplify the load, and that larger load is our factored state, that is P sub U. U represents ultimate state, meaning you need to factor out, so we need to magnify. So, magnified load value yan. Okay? Magnified load value. So, how do we magnify the load value? There are certain load combinations to consider. Yan. So, may pang dead load, nomenclature for dead, nomenclature for the earthquake, nomenclature for the estimated maximum earthquake. Ito yung may point of exceedance sa load fluids, load due to fluids, and the load due to lateral force, L, and so on, no? Panding load. Tingnan natin kung ano yung applicable. Of course, don't forget the wind. And here are the load combinations. So the main objective of using this is to make sure that all of this code are used to validate the most critical. So meaning the most critical should be the largest load combination. Ngayon, if the dead load and live load lang usually ang ginagamit, and D represents dead load and L represents live load here, so most likely, these first two will be the highly usable equation that can provide larger, no, largest value. Now, in case of doubt, you can use all of these and then identify kung saan siya mag-exist ang pinakamalaki. Pag dead load and live load, it's either the first or the second ang nagkakaroon ng talagang interaction na may malaki. Usually, it is a second usually. But don't forget that sometimes it is the first, depende sa largest. So, it is safe to say na lang to use this all and then validate kung saan may kinalaman dead and load. Lalo na pag may wind and earthquake ka. No, nagkakaroon pa ng fluctuation sa possible largest. Sige, let's try to apply that. Kaya nagkaroon na ito. Don't forget that PDL is 300 and PLL is 107. So, first code, if you recall, this is the 1.4 of PDL as written kanina. And kapag may combination sa dead and live, 1.2 dead load plus 1.6 of live load as shown kanina. So this is the first two code. And then we obtain these two. And then choosing the largest as the most critical, that is 531.2. That's why 531.2 is the value for P sub u that we need to compute, no, to be analyzing, no. I mean, that's part of the section to be analyzed. So using PU of 531.2, then we will arrive to the following next set of equation. Okay, knowing that PU is 531.2 to represent these two laws in terms of LRFD, okay, then followed by what we call the collapse mechanism diagram, or we will use CMD for this, okay. So ano yung mga nakikita natin? If we have a support at A and B, as discussed in the video presentation for collapse mechanism, if there's a true hinge, then we will call this as real hinge, ano? Real hinge. Ibig sabihin, may totoong hinge or roller ka dyan. And we will try to write RH for that. Kaya that's why you will find it, this is RH, okay? So both A and B is RH or real hinge since there's a true hinge, no? While at just directly below, yung mismo magsasag na segment or directly below the load. So ito yung PH, no? Yung binulugan ko. Why PH yan? Kasi that is what we call plastic hinge. Okay? Plastic hinge, ibig sabihin yan, wala ka talagang totoong hinge yan or walang real hinge yan. Pero there's a tendency na tumupi because under the segment, if you will go back to my past discussion regarding this, so the segment will look like this, no? Meron ka ditong para magtutupian na portion that is found on directly below pag concentrated na single. Okay, so therefore, para mangyari is at the point of collapse, no? Yan, kunyari, ito yung nagkaroon ng point of collapse. So, nagkaroon ka na dito. So, actually, may curvature dito eh. Yan. So, ito yung point of collapse. Yan, yung nagkaroon ng hinge effect. Okay? So, that's the idea. So, nagkakaroon ng hinge effect directly below kapag concentrated. Kaya plastic hinge yan. And on the plastic hinge is the value of plastic moment. Okay? So, that's what we are going to include. So, for every plastic hinge is an equivalent value of plastic moment. Sabihin, ito yung plastic moment na magbibigay sa kanya ng rotation for this hinging to take effect. And then, other parts, of course, at point A, there's a slope at A. At B, there's a slope at B. And by these statements, sige, burahin natin para hindi medyo masakit sa mata, no? Marami na figure. And then finally, if you will take a look on this, no? If you continue the line on A and rotate that about going to B, so may makukuha yan deviatory plastic slope, like let us call it delta theta sub P. So if you notice that algebra, no? This angle and this angle is equal, and this angle is adjacent, no, adjacent, meaning you're going to take a look that this is theta b, this is theta sub a based on trigonometry, and there the sum theta a plus theta b is what you call the plastic deviatoric slope na kasama sa portion. Ngayon, si plastic deviatoric slope ay merong kinalaman sa hinging on point. Let us call this as point C. Yung joint na yan, na sinaydan, na bilog na region. Okay? So, how do we calculate this? Again, let's start with the small angle theorem. So, how do you start with this, no? Notice that on the left side, I can draw, okay, a triangle, but before this, note that there's a value of delta. Deflection yan due to plastic deformation. So, delta, straight line. And then you notice that there is a triangle. No? I'll try to shade it as red, no? Para visible. Oops, it looks like na triangle in my drawing. So, let me fix this. Ayan. No? Shade ako ng red. Ayan, yun, no? Ginuguhit ako ng red. And then, I'll try to shade it red para mas visible. Ayan, no? So, what is being shaded is a triangle portion. And also, on the other side, I'll try to use a violet colored marker. Okay? Ito yung kabila, yung nasa kanan. Okay? So, therefore, if I were to shade it also the same color, violet, then that's it, no? So, meron dalawang triangle. And then, you notice that it is applicable to tangent of the angle. So, we can have this, no? So, theta sa base delta over 6. And theta base delta over 6 also. Kasi equal naman yung distances nung dalawang portion. So, kasi nasa gitna. Okay? So, we can safely say that delta is 6 theta A equals 6 theta B because these two deltas are equal based on the image. And then we can say that theta A is equal to theta B. Okay? So therefore, if I were to take the sum of the plastic slope, no, yung delta theta P equals theta A plus theta B. So that looks like theta A plus theta A, where theta is equal to theta B. So we can safely say na 2 theta sub A na yan, or we can say 2 theta B. Ngayon, let us apply the virtual work method. Don't forget that it is energy in equals energy out. And the energy in is due to the nominal concentrated load multiplied by the deflection cost. No? Yan yung energy. So, para mag-deflect siya ng ganyan, kailangan mo ng nominal state na force para mag-deflect siya of an amount delta. Okay. Why nominal? Kasi as of the code, sabi diyan, a collapse mechanism can only be found at nominal state. So hindi siya actually ultimate state ano? Pero in correlation to ultimate and nominal, don't forget that the ultimate equals phi of bending times the nominal. So we can say that there's a relation between the two. So nominal equals PU over phi of B, or the phi of bending. No, the reduction factor for bending. That's why you'll find out in my equation, Pn equals Pu over phi B na. Kasi ang plastic moment will only exist in the condition of nominal state. Okay? And the rest, no? Now, ngayon, you will notice that there is equal to plastic moment, that is the energy na mai-release kasi siya ay pinaka-producing force, and times the sigma of the theta. Okay? So, ngayon, you have to take all the angle. So, let me erase this first. Yan, para mas malinaw. Okay? Now, you have to take a look of all the angles. Yung magkabilang dulong angle at saka yung plastic deviatoric slope, where it is theta A plus theta B, then it is highly visible. Ito yung nasa kaliwa, ito yung nasa kanan, at ito yung delta theta P, where delta theta P is theta A plus theta B. Now, the value of theta, and after you have found that it is real hinge or plastic hinge, the value of the real hinge ng theta niyan dapat 0 pagdating sa loob. While pH, or there should be an angle of theta, regardless of A or B. Depende kasi yan kung ano yung gusto mong i-take na consideration. So therefore, automatic that at both sides, it is set to 0. You notice why 0? Kasi ang A at ang B are both real hinge in this concept. Okay? And then, why you found out this is 2 theta A? Kasi that is the plastic deviatories that we have performed earlier. This one. So, delta theta P is just only theta A plus theta B. Ang is really existing. Regardless of real hinge ba yung magkabilang dulong support. Okay? So, therefore, notice that our ultimate load is 531.2. O so, pwede mo na computein actually. Yung PN dito pa lang, pwede mo na is ilagay. But of course, for clarity, nilagay ko lang na sa equation. So, that's why it is 531.2 over 0.9. Okay, times 6. Okay, why did I choose 6 theta A? Kasi sa kabila, you will notice that MP is a function of theta sub A. Ngayon, if I choose 6 theta B, kasi delta A is 2 values here, no? Pwede 6 theta A or 6 theta B. If I use 6 theta B, I cannot resolve the exact value of MP kasi theta A over theta B lalabas unless you will have the same function, theta A. And you notice that I can cancel theta sub A. So, the plastic moment does not is not dependent na malaki do sa thetas at A or B regardless. As long as there is an equality function of the function for theta A, theta B, and the plastic deviatory slope. Then by findings, you can calculate as 531, 5,312 over 3 kilonewton meter. Or roughly estimated 1,770.6667. So So, this will be our answer, the plastic moment condition. So, ito pa hinahanap ng problem. Kaya tingnan natin, ano ba yung implication niya? No, pag tinignan natin yung elastic theory niya or yung napag-aralan na natin before sa strength of material sa pagdodrawing ng shear and moment diagram. But of course, let us talk about moment diagram. Kasi madali na may-drawing moment diagram under elastic theory. Okay, based on your strength of materials, no, ma-understand nyo na pag dinowing natin, ito siya, no, moment diagram. So, PUL over 4. So, that's why we can have moment as 1,593.6 if under MU. But again, for us to compare the plastic moment, kailangan ang pang-comparison natin sa moment diagram should be in nominal. So, therefore, after taking that, then you can have this, no, same answer sila. Again, that PUL over 4 is derived from strength of materials. So, yung moment diagram that we already know before. So notice that they are the same. Ano po ibig sabihin nito? Ibig sabihin yan, ang action ng hinging effect sa under collapse at saka ng under elastic theory are the same. No? So, it can immediately happen under collapse. Ibig sabihin yan, pag dinowing ko yung moment diagram under collapse is ganun din mapoproduce natin. No? So, that is the MP. Kumbaga. And you will notice that they will be equal. Ito yung under collapse, collapse mechanism, or not CP, that is CM, okay? And the other one is for elastic theory. Simply moment diagram na lang. O, CMD. Yan. Parang ang nangyari, ito, tsaka to, same lang. Nangyari, ito in figure, okay? At ito naman in energy illustration. Okay? So, notice that they are the same. Now, what if the concentrated load is wala sa gitna? So, let's take a look at the next problem. So, this time, 3 meters away na siya from A. And same load. So, we will do the same. Computing the following. Of course, you have to determine the plastic moment of the given beam span. Okay, same routine, then you will eventually get the same value, 531.2 kilonewton for PU. No, load factoring ito ulit. Okay, so this time, basta notice nyo, pag may binilugan ako sa sinaydan ko, yan yung mga portion of the hinges. Okay? So, this time, again, this is A, this is B. So, therefore, ang nangyari, this is real hinge, another real hinge, and then plastic hinge sa ilalim ng load mismo. And kung nasa plastic hinge, may ikot dapat na plastic moment. Same condition, may theta sa B ka dito, sa kaliwa, may theta B ka sa kanan, at meron kang titawag na plastic deviatoric slope or deviatoric plastic slope na equal sa sum ng magkabila ang slope. No, already discussed using trigonometry ito, tsaka linear, at tsaka algebra. This is what you call the collapse mechanism diagram. Okay? So, notice, ganun ulit ang mangyayari. You will have series of triangles to understand. Okay? So, may triangle ka sa kaliwa. Okay? Shadean ulit natin ng red. Okay? This one. So, meron kang triangle naman sa kanan. Let's say, let's use a violet color mark at saka shader. Okay? So, ganun po ulit, right triangle rule ito. Gagamit ka lang ng tangent angle, opposite over adjacent, or using small angle theorem, magiging in terms of radians na yan. Okay? So, by continuation, you will have the following. So, again, theta A is equal to delta 3, delta over 3, and delta B is delta over 5. So, since delta are the same to both dimension, kasi nagkaharapan lang yung dalawang triangle, the same theta, this is theta A, this is theta B, while this is 5 meters, this is 3. So, you can easily use the tangent angle, adjacent, opposite over adjacent. Then, delta is said to be 3 theta A is also equal to 5 theta B. So, I can now correlate theta A in terms of theta B. Or if you want, you can say, you can calculate theta B in terms of theta A. So, magiging 3/5 lang yan of theta sub A. Don't worry, they will have the same answer. And then for the plastic deviatoric slope, the sum of the adjacent angle, which is 5/3 theta B plus theta B equals 8/3 theta B. Kasi theta sub A is interpreted as 5/3 of theta B. So, naka-plug in lang yan sa loob. So, notice that the delta theta P is 8/3 of theta B, no? And then finally, energy is equal to energy out. So, same concept sa pag-calculate. So, at nominal lagi po ito. So, don't factor it unless your load is taken from the factor state. Then, you have to bring it back to nominal state. So, if the load is already unfactored, pagdating sa given, let's say, binigyan ka ng load na ito, let's say 150 kilonewton, hindi mo alam kung unfactored yan or factored, simply that's already the nominal state value. So there's no worry kung pa-factor nyo pa sa i-unfactor, just simply plug it inside. Now, I clearly stated here that if the statement does not say kung ano yung 150 kilonewton, the assumption is already under nominal. Unlike sa given natin, given na dead load at saka live load. So meaning, there's a need to convert it to live to ultimate and then bring it back to nominal. Okay? Again, same concept, PU over phi B, where phi B is 0.9. Okay? Then you will get this, no? So, equals MP is equal to sigma theta, energy is equal to energy out. Don't forget. So, again, writing this, theta A plus delta theta P, where delta theta P, or the plastic deviatory slope, is theta sub A plus theta B, plus the another hinge value, theta B. Again, don't forget that theta sub A and theta sub B in the figure on both sides are both real hinge, so therefore set to 0. And delta theta P is theta A plus theta B. We already have 8/3 of theta B. Then we will have the following equation. So finally, you will get 3,320 over 3 kilonewton meter, or roughly estimated 1,106.6667 kilonewton meter. By the way, ano ba yung concept pala ng collapse mechanism as a diagram? Usually, si collapse mechanism, nagbumukha siyang unstable no? But not really unstable. Kaya that's why, there's what we call unstable, but there's what we call a mechanism. Kaya nga, tinawag siya mechanism kasi, even though it looks like it is not functional, there's a system happening. And the mechanism goes on the concept of the plastic moment. Siya yung pinaka-mekanismo para masabi natin, nagkakaroon siya ng pagtupi, katulad nung dinidiscuss natin on the previous problem and also to the concept and the principle it goes with respect to the direct, no? Yung conceptualization ng paano nangyari yung collapse mechanism. So finally, you will understand that this is the same plastic moment that should be found, no? Kapag kinumpare natin sa elastic theory. Is it correct? Let us find out. Again, this 996 kilonewton meter looks like our M sub U, but M sub U. This is calculated based on PU of 531.2. So, you can verify. So, by computing the reactions, so, ang reaction niya ng kabila, no, under ultimate, that is around, let me calculate, times 5 divided by 8, that is 332, okay? And the other side, just simply deduct it, so magiging 199.2. So therefore, 332 times 3 is 996, or simply 199.2 times 5 is also the same value. That's under ultimate. Bakit? Yung load kasi natin P sub U, factored yan, right? If you recall. But again, for better comparison, you have to compare the plastic moment by the nominal moment, where MU is provided as 996. And then you can get Mn is equal to Mu over phi, which is phi is 0.9. Then notice that they are the same. Again, the same definition, but sila nagkaroon ng significance na equal kasi nga both of them are having the same function, no? Parang between elastic and collapse they are the same. So meaning, in this concept, we can safely conclude that in a single concentrated load applied on a single span that is determinate, meaning this is not restrained or prop beam, we can find out that the nominal moment is equivalent to the plastic moment. That validates one of the theorem under static, under the dynamic, if there's a larger degree of freedom, and there's what you call uniqueness theorem. So that this is the validation of which, no, do sa mga nasabi natin. Okay, thanks for viewing. I hope you learned something new today. And as our tradition, you have been neurorized, and see you in our next video lecture.